All right, example 2, use substitution to solve 3x minus y equals 11 and 2x minus plus 3y equals negative 11. This one doesn't have that x equals or y equals look to begin with, but it does have a coefficient of negative 1. So again, if I'm going to use substitution, I want at least to have that. Because if I have any number in front of, like if that says 3x and 4y and 2x and 7y, whatever, I'm going to have to divide, I'm going to get this fraction structure to substitute in. Those become difficult, okay, more challenging than the elimination method. So if I take this top equation, watch what I can do to it. I'm going to keep 3x where it's at. I'm going to move 11 to the left and y to the right. That's the easiest way to make it happen. If I got a minus letter, I just move the negative letter over here and everything else to the other side. That gets me a positive y equals 3x minus 11. And just like the last problem now, this right here is a true statement. Y is equivalent to 3x minus 11, which means this y can be changed into 3x minus 11. Changing one thing into multiple things, so parentheses will be necessary. So I take my bottom equation here, 2x stays 2x, plus 3 stays plus 3, y becomes 3x minus 11, and equals negative 11 still equals negative 11. So you maintain exactly the same equation that you have. The one change is that this letter gets changed into the expression that it equals. One object gets replaced with multiple objects, so parentheses have to be used. And again, the power in that statement and in doing that is this 2x plus 3y equals negative 11 makes a line, about like that maybe, all right, that has infinity answers. Every point on the line represents an answer. This gets us the x we're looking for. This has one answer, just x. So, solving it. 3 times 3x, 3 times negative 11. Again, distributive property. Very often distributive property is used because very often you're replacing one object with multiple objects. So 2x plus 9x minus 33 equals negative 11. Move the 33 over. 2x and 9x makes 11x. Negative 11 plus 33 makes 22. Opposite sign subtract. 22 is bigger, or sorry, 33 is bigger, so it's positive. We divide both sides by 11. That leaves me with x equals 2. I'm looking for an ordered pair. 2 comma something now. This time we found x first, so I'm putting that in the x position. In order to find out what y equals, this x equals 2. There's an x. So I'm going to take this expression here. It says 3x, changing x into a 2, minus 11 equals y. Again, just another substitution. X equals 2, x is right there, 3 times 2 instead of 3 times x, minus 11 equals y. That's 6 minus 11 equals y, so that means negative 5 equals y. So y is negative 5, we found both x and y, we have our answer. Alright, substitution again with linear equations works 100% of the time. Okay, so does elimination. Don't get to a point where you're just using one every single time. Use both, get good at both, because again, when we get to nonlinear systems this year, x squareds, y squareds, x times y show up, we have to use substitution sometimes. We have to use elimination other times. We have to be good at both. So be practicing both. This is review. You learned it last year in Algebra 1. You did pretty well with it last year in Algebra 1, so it should be good stuff. But pay attention to detail. Make sure you're answering the question properly. Show your work. Go through the process. Think through what you're doing as you're doing it. It will benefit you down the road.